the chemical equation. So at this point we are ready to mix a bunch of different substances and have them form new substances. And in order to show that, we use something called the chemical equation. You may have, well, definitely you have seen a mathematical equation where, for example, you write an algebraic mathematical equation as 2x plus 3x equals 5x. Similarly, we have something called a chemical equation. There are things on the left like 2x, 3x you have in the math, we have things on the left. But what separates the left from the right is not the equal to sign but an arrow, as you will soon see. And what's to the left of the arrow are called reactants, which are your starting materials. And what's on the right are called products, which are produced by that reactants reacting. And when the reactants react, we call it a reaction. Yeah, so the chemical equation shows a chemical reaction. It's a shorthand notation of a chemical reaction. A few other things are involved, such as showing the physical states and other experimental conditions as well. Let's look at a very nice example of a chemical equation. And so here is a chemical equation, and here you have how many reactants. Here is that arrow. On the left side are the reactants, on the right side are the products. In this case you only have one reactant, but you could have more than one. You at least need one. And on the right side you have these two products. This is mercury oxide reacting, and it's going through a reaction called decomposition, which we'll learn about later, where it's just basically breaking into two parts, and the two parts are mercury and oxygen. Mercury is a liquid. Here is the physical state, L for liquid. You put this curvy parenthesis and in that you put the state. Original mercury oxide was solid, forms liquid mercury and oxygen gas. So what else do we see in this equation? What is this? This is the experimental condition. The experimental condition says that energy is needed. It's in the form of either light, heat, or some other form. Usually it's heat or light. So if I take mercury oxide, heat it up, it's going to decompose to give me liquid mercury and oxygen gas. That's what this chemical equation is showing. And so what are the features of the chemical equation? The reactants, the products. Reactants are written on the left, products on the right. Physical state next to the formula of each reactant product in parentheses. Any experimental condition shown over the arrow. And the last part is that the equation must be balanced, whatever that means. Well, if you look over here and you see that there is this look over here, you see that there is 2 next to mercury. Where does that 2 come from? Why do we need that 2? Okay. Well, if you look over here, you see a 2 here, and because that 2 is there, that tells me that there are 2 mercury atoms in the original formula of the compound. On the right side I must have 2 mercury atoms as well, otherwise I'm not balancing the equation. I'm losing 1 mercury, and that is not allowed for a particular law that I will mention later, which tells that you don't just poof things out of existence or poof things in existence. Also oxygen. Oxygen gas has the formula O2. Oxygen is one of the 7 diatomic molecules. Please memorize those 7. Oxygen, which is always O2, fluorine, which is F2, chlorine, which is Cl2, bromine, which is Br2, iodine, which is I2, nitrogen, which is N2, and lastly hydrogen, which is H2. Okay, so whenever you produce those, they will always be diatomic. And so whenever oxygen gas is produced, is diatomic, and so there are 2 oxygen atoms. This is why I have a 2 here. Okay. We'll talk about balancing the equation a little bit more in the later video, But before we do that, what does the chemical equation represent? A chemical equation represents a chemical reaction or a chemical change. One or more substances change to different substances, and the different substances that form the products may have different chemical and physical properties themselves. Whenever we carry out chemical reaction, we can write down the equation, the balanced equation. But without it, how do we know that a chemical reaction took place? If you do a reaction in the lab, how do you know that that was a chemical reaction? Well, there are some telltale signs such as a release of a gas, usually it's carbon dioxide, but could be hydrogen gas or oxygen gas that's released. So whenever you see gas bubbling out of a solution, or you know that there is some gas being released that you can actually find out, that's usually a sign that a chemical reaction took place. Another sign is formation of a precipitate or a solid. If you mix two liquids, two solutions, and suddenly you see something settling down at the bottom when those two are mixed, that's an example of a precipitate. For example, if you allow milk to spoil by keeping it outside of the refrigerator, you will see that it hardens and settles down, and that is a form of precipitation. Some chemical reaction is taking place inside that's creating some compound that is not dissolving. Other way of detecting whether a chemical reaction took place or not is the production of heat or absorbance of heat. Whenever you mix acid and bases, as if they are very strong acids and very strong bases, we'll learn about acids and bases in a later chapter, by the way, but they will release heat. Okay. There are some reactions where when you mix two things, they will absorb heat. In that case, the container becomes cold. That's usually a sign of a chemical reaction, but there are some exceptions. Sometimes when a chemical reaction doesn't take place, but just mixing happens, dissolving happens, that time too there is some release or absorbance of heat, and so heat change is not a definite sign, but it's an indication that there might be a chemical reaction. But finally, color changes. Color change is happening while the phase remains the same. That's a sign that a chemical reaction took place. If you had liquid oxygen that's blue in color and then it converts to gaseous oxygen, that's a state change, a phase change, or a physical process. Color did change there, but also it's the change in state. So that's not a sign that a chemical reaction took place. But if you have the same phase while the color changes, that's an sign that a chemical reaction took place. Okay. And here are some subtle signs. Electrical properties changing in the new compounds, so there are formed. If we can measure those electrical, how they behave in the electrical or magnetic field, how whether light or heat was emitted or absorbed, those are some subtle signs that a reaction took place. Once we know that a reaction took place, we can isolate the products, and we know what the products are, then we can write down the reactants products on each side of the chemical equation and balance out the equation to give us the balanced chemical equation. There are many different kinds of chemical reactions for which we can write down the balanced equation, and we are going to look at all of them in the next video.